Hello, dear students of 10th class, respected teachers and respected parents. So, in this video, I am going to discuss a part of the chapter electricity, in which I will discuss what is electric current, what is electric potential, what is electric potential difference, and what is drift velocity, and what are the units of current potential. So, let us start. First of all, what is electric current? So, electric current is defined as the rate of flow of charge. That is, charge flowing per second is called electric current. So, I is given by Q upon T, charge flowing per second, where Q is equal to N into E, where N is the number of electrons moving through the conductor, and E charge upon each electron, which is minus 1.6 into 10 raised to the minus 19 coulomb. Charge upon electron is negative, proton is positive, same amount. So, if Q is equal to unit of charge is 1 coulomb in SI system, coulomb is unit of charge in SI system, E is equal to 1.6 into 10 raised to minus 19 coulomb, then N will be equal to Q upon E, that is 1 upon 1.6 into 10 raised to minus 19. So, it comes out to be N is equal to 6.25 into 10 raised to 18. 10 raised to 18. So, it means 1 coulomb of charge is that charge which is contained by 6.25 into 10 raised to 18 electrons. ਇੰਨੇ ਇਲੈਕਟ੍ਰੋਨਸ ਹੋਣਗੇ ਉਹਨਾਂ ਤੇ ਟੋਟਲ ਚਾਰਜ ਹੋਗਾ ਉਹਨੂੰ ਅਸੀਂ 1 ਕੂਲਮ ਕਵਾਂਗੇ okay and in SI system unit of electric current is I is equal to ampere. So 1 ampere is defined as 1 coulomb or 1 second, that is 1 coulomb per second. So electric current is said to be 1 ampere when 1 coulomb of charge flows in 1 second. So this is 1 ampere. So ampere is unit of electric current in SI system. Coulomb is unit of charge in SI system. Current is rate of flow of charge. Okay. Now current is scalar quantity. It is scalar. But it has a conventional direction. So direction of current is taken from positive end of the conductor to the negative end of the conductor. That is opposite to the flow of electrons or in the direction of positive charge carriers. Otherwise, it is a scalar quantity. Now we define electric potential. Electric potential. Now, electric potential is defined as the amount of work done in bringing a unit charge from infinity to the given point. Now suppose we have a given charge Q. In the space surrounding it, its effect can be felt. Means if we place any other charge plus 1 coulomb, unit charge suppose, and when unit charge is brought close to the charge Q, work has to be done. Or this amount of work done in bringing a unit charge from infinity to the given point, say point P. Amount of work done in bringing unit charge from infinity to the given point is known as electric potential at that point. If we have to define potential difference between 2 points A and B, suppose A and B, then amount of work done in bringing again a unit charge from one point to another point. That is called potential difference between 2 points, because at infinity potential is 0. So we take simply electric potential at a given point. And at A and B at finite distances, potential is not 0, so we define potential difference. So there is a difference between potential difference and electric potential. So again I repeat, electric potential is the amount of work done in bringing a unit charge from one infinity to given point. Potential difference defined as the amount of work done in bringing a unit charge from one point to another point. Clear? So electric potential V is defined as amount of work done per unit charge. Amount of work done in bringing unit charge, work done per unit charge, or if work done is in joule, charge in coulomb, so this 1 joule per coulomb is known as 1 volt. So volt is unit of electric potential in SI system. So electric potential or potential difference between 2 points is said to be 1 volt. When 1 joule of work is done in bringing 1 coulomb charge from one point to another point. Simple. So SI unit of electric potential or potential difference is 1 volt. It's also a scalar quantity. Now, suppose we have conductor. Conductor, there are large number of free electrons which move in random fashion. Free electrons move in random fashion when there is no potential difference. Potential difference is 0. Means there is no current. Even then, there in the conductor there are large number of free electrons which move in random fashion or zigzag path, follow zigzag path. So net flow of charge is 0. If net flow of charge is 0 in a particular direction, then there is no current. So current is 0. So current flows only when there is net flow of charge in a particular direction. So when there is no potential difference, but in conductor there are large number of free electrons which move in random fashion, but net flow of with very large speeds of the order of 5 meter per second. But there net flow is 0. Therefore, there is no current. But when a potential difference is applied, the positive negative battery is connected to the connector. This is positive end, this is negative end. Then each and every free electron is directed toward the positive end, because the electron is negatively charged particle. It is directed toward the positive end of the connector. So electrons are flowing in this direction, and some current starts flowing through the connector because there is net flow of electrons in a particular connector. Clear? Now, when one electron reaches the positive end, it is swept out by the positive terminal of the battery. And at the same time, one electron is given out by the negative terminal of the battery. The total number of free electrons inside the connector remain the same. That's why conductor carry current is neutral. There is no charge. But flow of electrons starts when potential difference is set up. And this velocity, average velocity of these free electrons with which they are drifted toward the positive end of the conductor under the influence of potential difference is known as drift velocity, which is very small, which is of the order of 10 minus 4 minus 5 meter per second as compared to velocity of free electrons when there is no potential difference. Why this drift velocity is small? Because when electrons move in a particular direction, they have to collide with the atoms or molecules of the connector. Due to this potential difference, they gain their speed, they gain kinetic energy, but they have to collide with the atoms or molecules of connector. In other words, they have to follow through inelastic collisions. So the kinetic energy gained by electron due to potential difference is lost at every collision, which appears in the form of heat. And this phenomenon is also known as resistance of the conductor, that I will discuss later on when I will discuss Ohm's law. So that's why when current is passed through a conductor, wire gets heated due to this loss of kinetic energy gained by electrons due to potential difference and lost due to inelastic collisions of the free electrons with the atoms or molecules of the conductor. So that's why there is heat produced, wire gets heated when current passes through the wire. So this is what we known as drift velocity. So we have discussed what is electric current, rate of flow of charge flowing per second is called electric current. Unit of electric current is ampere in SI system. Current is said to be 1 ampere when 1 coulomb charge flows in 1 second. Then electric potential, amount of work done in bringing a unit charge from infinity to a given point in the field of a given charge. So potential difference, amount of work done in bringing a unit charge from one point to another point. So potential or potential difference is measured in volt. Volt is SI unit of electric potential. Both electric current, charge, and potential are scalar quantities, but current has conventional direction which is opposite to the flow of electrons. The direction of flow of electrons is called electronic current, and direction of flow of positive charge carriers or opposite to flow of electrons is called conventional current. So drift velocity, the velocity with which each and every free electron is drifted toward the positive end when potential difference is applied is called drift velocity. Drift velocity is too small because it has free electrons has to collide with atoms or molecules of matter due to whenever they are moving from one end to another end. So this is all about these basic electric current, electric potential, potential difference, and drift velocity. The next video I will discuss Ohm's law and resistance. Till then, goodbye, be happy, all the best. ਜੇ ਤੁਹਾਨੂੰ ਇਹ ਵੀਡੀਓ ਮੇਰੀ ਵਧੀਆ ਲੱਗਦੀ ਹੈ ਆਪਣੇ ਦੋਸਤਾਂ ਨੂੰ ਸ਼ੇਅਰ ਕਰੋ, ਲਾਈਕ ਕਰੋ, ਕਮੈਂਟ ਕਰੋ ਔਰ 9 to 12 ਲੈ ਕੇ ਸਾਰੀਆਂ ਕਲਾਸ ਦੇ ਫਿਜ਼ਿਕਸ ਦੇ ਲੈਕਚਰ ਨੇ ਔਰ ਮੇਰੀ ਮੋਟੀਵੇਸ਼ਨਲ ਵੀਡੀਓ ਵੀ ਫਾਲੋ ਕਰੋ ਔਰ ਤੁਹਾਨੂੰ ਬੈਨੀਫਿਟ ਹੋਏਗਾ। ਥੈਂਕ ਯੂ, ਗੁੱਡ ਲੱਕ, ਆਲ ਦਾ ਬੈਸਟ।